If that says radian on yours, here's how you change it, okay? So you press mode, and then you see that the third line down, right? If radian is highlighted, so you press mode, right, to get to this. You want to make sure you go to the degree and hit enter so that that is selected. If yours is already selected, if degree is selected for yours, you're fine, nothing to change. But make sure that is moving forward. You need to have that, and it should say the degrees at the top here. Then you know you're right. Okay. Otherwise, you're going to get the wrong answers. So the trigonometry that we're going to learn is not like if you're thinking SOHCAHTOA. I don't know if your teachers used SOHCAHTOA like sine, cosine, and tangent. We're not going to use that anymore. Okay. So if you're like this, I'm only going to teach you two laws, right? Sine law and cosine law, and that's all you need to solve any triangle. Okay. There's no tangent law. There's this sine and cosine law, right? So today I'm just going to teach you how to use sine law, and then tomorrow or maybe the next day we'll introduce cosine law. And once you have those tools, then we're going to start solving problems, and I'll obviously introduce different scenarios to you. So let's go to page 2 here, Intro to Sine Law. And if you have a few highlighters, it's probably a good idea. If you've been creating your study sheet, you probably know highlighting is important. Okay, so in Intro to Applied and Pre-Cal, okay, you learned about the primary trig ratios. Okay, so you learned about sine, cosine, tan, and you also learned about sine inverse, cosine inverse, and tangent inverse, right? These here allowed you to solve for an angle, right? But remember, sine of an angle, cosine of an angle, tangent of an angle is really a number, right? It's based on the unit circle. If that doesn't mean anything to you, don't worry about it. So you learned about the primary trig ratios, okay? Primary trig ratios. Everybody has the booklet, right? We all grabbed one. If not, there are extras here. Primary trig ratios only work with right triangles. So in grade 11 applied, we will learn how to solve oblique triangles. So those are all triangles that aren't right triangles. Okay. So last year, you would have had, right, a right triangle like this, or you may have had it upside down like this. Regardless, that is SOHCAHTOA. I would have taught it this way. Okay. No more. So these are right triangles. Okay? It only works for right triangles. Let's get rid of all that stuff there. There we go. But now we're going to go with oblique. So oblique, I always want you to, the traditional triangle is a little offset. So you have a roof here, and then the other side is a little longer. Okay. So you may have an acute oblique, and it just means that all angles are less than 90, okay? Or you may have an obtuse oblique. This one right here. What does oblique mean again? Any triangle that isn't a right triangle is in the oblique category. I'm not going to be using oblique a whole lot in general, but I'm just letting you know that's what it means. Obtuse, what qualifies as an obtuse oblique triangle? Sorry, I forgot to put the triangle in there. You need one angle greater than 90 degrees. Okay. One angle greater than 90. So here's the sine law. Sine law states the following. So let's draw a triangle right here. Like that. And I'm not going to use ABC. Often we use ABC. I'm going to go X, Y, Z, right? Because otherwise we think we're too fixated with the ABC, right? So if these are capitals at the corner, we have lowercase, right? If this is angle X, across from it is side X. Angle Y has side Y across from it. Angle Z has side Z across from it. And sine law states this, that if you were to take sine of X, let's say, and put the side length underneath it, that would be exactly the same as going sine of angle Y over side Y, okay, and which is the same as sine of angle Z over Z, okay. And there's always a pair, they're always in pairs, always across from each other. So that is the important thing. So for example, if, right, this angle right here is across, they're across, so they're right here. Okay, you should see that they're opposite each other. Or Y, right? Y up here is across side Y. There you have your pair. And then this angle here is across X, right? So you've got your third pair. And so this is a property that we take advantage of, right? Knowing this, we can solve for missing angles or missing sides. All we need is at least one pair that is known to us, okay? So we need to know the angle and the side across from it, and then at least one other item, and then we can solve. I'll tell you this, that you could set it up this way, or you can flip-flop. You can have the side lengths on top and the sine underneath. I prefer this one here, to be honest. So I'm just going to show you that it is possible. Let's say someone is helping you with this down the road, and they're like, well, I use this method. Sure, it still works. It doesn't hurt. So regardless, you have they're paired up. Okay, so there we go. And underneath I have a triangle that is actually drawn to scale. Right, so we've got sine of A, right? So technically if we follow this, if we go sine of 22.7 degrees, what should go underneath it? The side length that's across that angle, right? This one right here, 3.74. This is actually drawn to scale, okay? I use GeoGebra for that. I don't know if you've heard of that before. It's a free software online. So we go sine of 55.9 over 8.03. And last but not least, sine of 101.39 divided by 9.51. I don't know if your teachers in the past have told you about this, but what do we know about, like if you have the largest angle, right? The largest angle is this one right here. Then you will always have the longest side across from it. Have you been told that? Okay. Remember when you use with right triangles, which one was always the longest side? It was across the 90, right? There was a hypotenuse. Because 90 was always the greatest angle in your scenarios. That's why. But so this is very important actually for you to understand. Let me try this here with the pen here. But the bigger the angle gets, like if I were to increase the angle here at this corner right here, right? This is 101 right now. If I were to make it even bigger, right, this side would continue to increase. Okay, and if I make that angle smaller, then this would get shorter, right? So that's the reasoning behind it. So largest angle has the longest side across from it. The smallest angle, which is this one, will have the shortest side across from it. And I don't know, the middleist angle has the middleist side across from it. That's not even a term, but That's literally how it goes. If you don't see that, then you're doing something wrong, okay? In your math. Later on, we're going to check our work with that. So let's do this. Type in at least one so you know how to do it. Okay, so sine of 22.7, okay? Close the bracket there. It's safer to do so. Divide by 3.74. You should get 0.103 and something. We'll just go dot, dot, dot. Is equal to sine of 55.9 divided by 8.03. That's 0.1031, and it keeps going. And then last but not least, and notice that that's some obtuse angle. There we go. You get the same. It's a little off, right? You notice that? These ones were had a 1 there. This one is 0.8. But they're close enough, right? And the reason is that if I used my angles here, I rounded them all to 1 decimal, or some of them I rounded to 2. But if I used all decimals, this would all be exactly the same. Okay, so there it is. Now you know that works. Sine law is accurate. You don't have to just take my word for it. Okay. Just one little comment. If you were to not see this triangle, something is wrong with this triangle. Right? It's not a triangle actually. It doesn't exist. So let's keep going. For sine law to work, you need at least one pair. That is important to highlight. And sine law works in the following cases. I don't need you to necessarily memorize this, but we call them angle, side is one of them. And so basically, it just means that you know the value of two angles and one of the sides. And I don't know if you see the pair. Obviously the check marks would be numbers, but there you see your pair. Okay, let's make one that doesn't look like, we'll make one upside down. Right, but let's say you know this angle and that angle, and then this side here. Again, you have your pair there. That's a dead giveaway that this is going to be sine law. Okay, down the road you have to choose between sine law and cosine law. If you have a pair, you know it is sine law. Then we have something called SSA. And guess what? It means that you have two sides and an angle. So you may have this side, and let's say you have this angle here in the corner. You still see the pair. And then you have the last one is ASA, angle, side, angle. And that's where the order, like I look at it that way. Angle, you have the side that connects them and then the other angle. So you've got the two angles connected by the side. This one is probably the easiest to identify here. Do you see a pair? No? But can you find a pair? If you've got two angles, you can find a third one, no problem, right? So we use sum of triangle to figure out this one, and then there it gets a check mark, and all of a sudden you do have. So if you have two angles, chances are you're going to be able to find, well, you know you can find a third angle. So this is what I call the hidden pair. All right, so it works in three cases. That's something to note. Let's keep going here. You should remember this: largest angles across the longest side. and smallest angle is across the shortest side. Because sometimes I'll ask you, hey, solve the largest angle. Solve for the largest angle. I won't tell you solve for angle B. I'll say solve for the largest angle, right? Or the longest side, or smallest angle, shortest side. You should know how to find them. Okay. A little bit of labeling. I need you to know if there's no diagram provided. When labeling, we use uppercase for angles, and lowercase for sides. Okay. I'll ask you to make a little change here. This is triangle DEF. Notice that there's a triangle symbol. Angle D is 60. I will call this F here. Angle F, because there's two angle Ds, right? Change this one to F and make it 80, please. I already changed it on the original this morning. Change that to F is equal to 80 degrees. You will always assume that it's not a right triangle in this unit, okay? Don't think it's a 90. So don't draw your triangles like you normally have, okay? So you just kind of go like this, offset. And it doesn't matter where you start. If you want to start up top, down here, this corner, but you just start and then start with the letters as depicted there. So I'm going clockwise, DEF, but it really doesn't matter if you go counterclockwise. You're gonna end up getting the same answers. So then we fill in the information. This is 60 degrees for angle D. Side D is 5.2, which means it should go right here. Angle F is 80 degrees, that would go here. And side F is 8.3. That means you would put it over here. Okay. And if you need the lowercase letters, just to make sure you understand that that's by definition, right? By default, that's how we label things, if it's not indicated otherwise. And now we're going to start our first example on solving for missing sides using sine law. So let's go to page 4. Determine the length of side B. That, right, if this is angle B, then this is side B right here. This question is specifically asking for that. Okay. And the first thing you want to ask yourself, is there a pair? Do you have an angle side pair? You do, right? Right here. So that's going to be dead giveaway, right? You've got a pair. Therefore, sine law. So down the road, if you see that, you know that that's what you need to do. Okay, so let's start our work here. That tells me I'm going to start with this as my pair, my original pair. 62 over 4.5 meters is equal to, what do I want to solve for here? I want to solve for side B, correct? So that's what goes down here. And what would I put at the top? What needs to be across from it? I always told you they go across, right? Angle B. I have a problem. I don't know angle B right now. So as is, I cannot solve it. But notice that there's two angles. I can easily find angle B. So I will just do that here. Angle B is 180 minus 38 minus 62. Angle B is 80 degrees. Important. Okay. So then I take this and I'll plug it in there. Sine of 80 degrees over B. And now I can solve it. This is now, you should recognize this as proportional reasoning, cross multiplying and dividing. So sine law has a lot of that. So remember, you go to the side where your variable is, you start with the number, you multiply this way, and then you divide. But that's not showing your work, that's just helping you out. So I want you to, not next to it, underneath it, say that b can be found by going 4.5 times sine of 80 divided by sine of 62. If you look at angle B, in terms of compared to the other ones, that would be the largest angle, correct? 80. So I'm expecting for this to be longer than that for sure. B is supposed to be longer. So let's grab our calculators. If you're asking yourself, why don't you go sine of 80 times 4.5? It doesn't matter. They're multiplying. That's all that matters. I tend to put the number in front of sine so it doesn't mix up the 80 and the 4.5 here. That's the only reason why I do that. So if you do it this way, you don't need to close, you don't need to close the bracket. So there's sine of 80. I hit enter at this point. And then I go divided by sine of 62, because then you don't have to close the bracket if you do it this way. So that's 5.02, right? And we are in meters. So now you solve for side B. Could you solve for side A as well? This one? Yes. But in this case, I tend to use my original pair as my setup. Then on this side, you would have gone sine of 38, right? Sine of 38, which is angle A, which would have allowed you to solve for side A, which is right here. In this case, I'm just going to stop there. I'm not going to continue. I'm going to ask you to try right after one example, because I believe in you guys. Based on what you've just seen, I want you to solve for side A here, given that scenario. Put it to the test. See what you get. You're supposed to get 8. Okay, I'll tell you already that it's 8 meters if you do that correctly. So give it a try. Then we'll do angle. Your main goal is trying to figure out a pair, if at all possible. So in this case, you don't have a pair at first, but you've got 2 angles. Your best bet is to go and figure out that angle right there. C is 65. Okay, so you can put that in there. And now you have the pair that we're talking about. So I always start with my pair. That's how I tend to start my work, even though it's not crucial. And if you choose to go sine of angle, you got to make sure there's a sine at the top and the side length underneath. It's asking for side A. A is right here. So I have to use this angle to get me there. Okay. So A is going to be found by going 14.5, right? You multiply these two. And then you divide by sine of 65. And if you did that correctly, you get 8 meters. It's 8.00 meters, 8 meters, it doesn't matter. That's the answer you get. Okay. Do you remember what solving a triangle meant? Solving a triangle means find all sides, all angles. Okay. So if that ever comes your way, that's what you need to do. So sine law and cosine law work with right triangles as well. So they solve all triangles if you're just careful. Let's go and solve for angles, and then I'm going to ask you to practice a bunch of scenarios where everything is mixed up and where it at first may seem like you can't. So here we're going to have applying the sine law to angles, solving angles, right? You're going to have to use sine inverse to do that. So triangle XYZ has the following dimensions: X, Z, angle X, right? And here's a question here. Do you notice a pair without graphing? Because this is going to come in handy later on. And I don't know if you see it, but you've got side X and angle X right there. That is a pair. So without graphing, I could tell you this. I could tell you that this is a sine law scenario without even graphing it. So let's sketch it and then calculate the values of angle Z and angle Y. So let's do A here. And when I sketch, I don't draw them to scale. Okay, so don't be going off of that. I'm going to go X, Y, Z. Angle X is 34. Side X is 6.2 centimeters. And this is 3 centimeters here. Okay, so regardless of what happens next, you should at least figure out this is sine law, right? So I'm going to start with that. Sine of 34 degrees over 6.2 centimeters. And you have to be smart about this. What is the first thing that I can solve for? Angle Z. Because you have the side across from it. So that is your only option right now. So that's what I'm going to do. I'm going to say sine of angle Z, which I don't know, is going to be across 3 centimeters. So initially this looks very similar to our solving for a side, except for here's the angle missing. Please don't omit this sine. Some students just go Z like that or Z. You got to make sure it has sine attached to it. So this is our variable, which means we start here, we cross multiply that way, and then divide going down. So multiply, divide. So watch this. This is where notation is important. You keep sine attached to angle, okay? And then you go 3 times sine of 34 over 6.2. And I will ask you to put, I normally don't like trains like that, but it's okay in this case. So you just multiply that out, right? You go 3 times sine of 34, enter, divided by 6.2. And I'm going to use a red pen for the first value there, 0. I don't know if you remember this from before, but if this doesn't start with a 0 and you're trying to solve for an angle, you made a mistake. It's not going to work out for you. So it better start with a 0, and then we'll just write down a few decimals, but I don't want you to round. We're going to use all of that. And this is where you apply the inverse. We basically apply the inverse to both sides. So angle Z is going to be sine inverse of this value here. And look up here. Let's make sure we know how to do this on our calculators. I would go second. As soon as you press second, you see the arrow up. Then you go sine, right? And then I just copy paste. I go up, highlight what I just got, enter to paste it into inverse sine, and then hit enter one more time. You get 15.70, right? 70. And this is where it probably differs from last year. I'm pretty sure you rounded to the nearest whole value for angles. Not anymore. Okay. I'm getting you ready for grade 12 applied, where everything is rounded to 2 decimals no matter what. Okay. So 15.70 is my angle there. How would I find angle Y? Because it asked me for it as well. Sum of triangles, that's right. So I'm going to go 180 minus 34 minus 15.70. Angle Y is 130.30 degrees. Okay. I just use sum of triangle to get that one. B, it's asking for, is this an acute or obtuse? And we now know it's an obtuse triangle. Because angles, oh sorry, angle Y, right? Sorry. Angle Y is greater than 90. So if all of them are less than 90, then it's an acute triangle. As soon as you have one that's bigger than 90, you have an obtuse. Before you go, but before I ask you to try a few on your own, because I'm going to mix this up. Sometimes you're going to solve for angles, sometimes for sides. What is C asking you to do? Solve for side Y. And you now have angle Y. So that shouldn't be a problem, right? So let's do it one more time. You can't blame, you can't say you don't give me enough examples, Mr. Dirksen. I hope you never say that. You can say on the review at the end, it was a bit boring. I fell asleep while you were talking. But you can't, I don't want to hear, you didn't give me enough examples, right? Sine of 34 over 6.2, I tend to start with the pair that I had right from the beginning. The OG, right? Hey, I was able to get that in there. And this is side Y, okay? And so now you do this whole thing again. And after a while, you're going to do this with your eyes closed. So if you feel like, you know, this is going to be easy, yeah, get really comfortable with this part, because once work problems come your way, that's when the challenge arises. Okay? If you do this correctly, 8.46 is the answer. Does it make sense? I'll just take a moment. 130 is the biggest, the largest angle. 8.46, as far as I know, is the longest side. Yeah, it is the longest side. So it checks out. So those are little checks that I want you to. Do you know what perimeter is? Measurement around, distance around. So if I ask you for that, you just have to go 3 plus 6.2 plus the one I just found. So that would be 17.66. It's the distance around. So sometimes the question doesn't ask you to solve for a single side. They'll just say, find the perimeter. And you're like, well, wait a minute, I need all the sides, right? So it's implied that you're going to have to do some solving before you find the perimeter. Okay. All right. Another thing I'm just going to warn you, sometimes, look up here for a second. So we did Y, we solved for Y, right? But we did a whole bunch of work before we got there. We solved for, we had to first solve for angle Z, then we solved for angle Y, then we solved for side Y. That is, it may be that the question asks you flat out solve for side Y, and you'd be like, I can't, not yet. Right? You have to do a little bit of work to get there. Okay, so just remember that when that arises. So I'm going to ask you to go and try pages 7 to 10 for now. If you want to do more, I'm not going to stop you. And I know this is a lot, and I need you to find, you know, your time management skills here. Once you've done a couple of these that are just triangles, here you go solve. I need you to try at least one or two where there's no diagram provided. So that's on page 9 and 10, right? So, and it only solve for what's indicated for the pages 7 and 8. So for example, the first one, was it asking for? Side B, right? This one over here, what is it asking for? That angle, right? Theta, it's asking solve for angle C. That's what. So I don't want you to solve the whole thing because it gets too tedious and too repetitive. So practice this, get really good at it, and if you have any questions, talk to me. All right. I'll pause it here.